Welcome to another Level 3 probability distributions video. This is our second video on Poisson distribution. Now, we talked in the last video how the Poisson distribution is recognized by a rate. For example, on average, we have 2.6 earthquakes per year. So it's that idea of per something, that rate, that makes it a Poisson distribution. Now, we had four conditions that must be met for Poisson. Each event is independent of others. Events must not occur simultaneously. Events must occur randomly. And the probability of an event occurring is proportional to the size of the interval. It's important to learn these four conditions because they could be talked about or asked about in the assessment. And there's one parameter you need to be mindful for the Poisson distribution, and it's this parameter called lambda. It's an expected value or mean or average, but it's unique because it's over a given time period. It's that idea of on average 2.6 earthquakes per year. All right, let's get into our example. It's the same example as the last video. It was about a region in the Pacific experiencing an average of 2.6 earthquakes each year over the Richter scale reading of 4. So we know straight away that lambda, or the expected value or mean, is 2.6 per year. And in the last video, we showed you how to set up your probability distribution table, and we drew a probability distribution graph so we could visualize what's going on. Now, what we're going to do is we're going to show you how we come up with these probabilities. Where does the calculator come up with these probabilities? So let's get started. The first thing we'll do is show you how to read off the Poisson distribution table. And this is going to be given in your formula sheet. So one way to find a probability for 4 is just to find where lambda is on your Poisson distribution table. Find lambda is 2.6. Once you've found lambda, read down to find your x value of 4. And then if you match those up, straight away you'll see the probability of having 4 earthquakes in a given year is 0.1414. Now that's quite useful and quick, and quicker than the calculator, to be honest, and you actually have the entire table set up ready to go if you wanted to draw your table or add up specific values and so on. Well, we're actually going to show you properly now where the number comes from, and it comes from the Poisson distribution formula, which is this formula here. Right, so let's show you how it works for the number x is equal to 4. Basically, every time you see this lambda, we're going to replace it with the average of 2.6. And every time we see x, we're going to replace it with 4. Now let's quickly show you what's going on the bottom of the fraction. 4 factorial, that exclamation mark is called factorial. And it basically means 4 times 3 times 2 times 1. 5 factorial means 5 times 4 times 3 times 2 times 1, and so on. There is a way to find it on your calculator. If you have a graphics calculator, go into run mode, go into the options and find extra options, and go into the probability menu. And inside that probability menu is your factorial button. So you just type 4 factorial and it comes up with 24. All calculators have the factorial button if you do need to find it. All right, let's show you how we work out this probability from this formula. So the first thing we need to do is start off and go 2.6 to the power of 4. Then we need to go times. Now we need to do this bit, which is E. E is that weird number. It's like pi. It's a unique number. And to get E, you have to push shift and then push your ln natural log button. And it'll come up with E to the power of something. I like to put it in brackets because it's negative. So I go brackets negative 2.6 and close my brackets. Then I need to close my brackets again to close off the entire top of the fraction. And then I need to divide by either divide 24, because if you know what 4 factorial is, or just divide by 4 factorial. And that gives you the probability of 0.1414, which we're going to round to 4 significant figures. Right, that's a lot to take in, so it'd be good to get away and do some practice on that. Thanks so much for watching.